a new problem here. So suppose this company, the same company, doesn't want to manufacture any units of product 3 unless it produces at least 40 units. This built on the previous problem with that fixed charging problem. Okay, now what it is saying is that this company does not want to build any units of product 3 unless they build at least 40. Can we write a simple constraint and say, okay, x3 greater than or equal to 40? Can we? Can we just write the constraint and say x3 greater than or equal to 40? If we have a constraint, say x3 greater than or equal to 40, that means this company has to produce this product and it has to produce at least 40 units. Okay, but what's the other situation this company can, what's the other option this company can do? Produce none of them. Right, produce 0 units for product 3, right? So with these two constraints, what we are saying is that x3 can be either way, right? At least 40 units or 0. Okay, so these are the two conditions. And when we are dealing with a situation like this, okay, so this value can be either greater than or equal to 40 or 0. We know that a simple constraint won't do it. We can just write this way. Does not work. Does not work. Okay. Then how do we formulate a condition? How do we formulate a constraint for this condition? And in this chapter, we talk about the binary variables and the advantages of binary variables. Last time we talked about in the fixed charge problem. They turn those values on or off, right? In the objective function, a few of you wrote that in the objective function of the fixed charge problem, it's the total profit subtract the y's times the setup cost, right? And those y's being binary turn the value on or off. So meaning the setup cost can be either 0 or 1,000 for the product 1, okay? And here, look at this, it's similar, right? What we're saying is, okay, we need to turn these two values either 0 or greater than or equal to 40. Okay, so instead of say equal to 40, we just change this to be greater than or equal to 40. So this leads us to think, okay, in situation like this, the binary variable, the use of binary variables will be very helpful. Okay, and what we want is to turn either of those values on or off. Okay, and then when we try to turn, say, like the setup cost, either be, this is the previous problem, okay, the one you just worked on. It's 1,000 for the first product, or 0. We use the what? Y1 times 1,000, right? When y equals to 1, we turn this 1,000 on. When y equals to be 0, we turn this on. So what do you think? To have this constraint, what do you write? What's the most intuitive answer?
Could we introduce another variable and do the same greater than 40, but only if we produce at least one of the things, like another y?
Yeah, yeah. Okay, so what's your suggestion?
It would be like x3 is greater than or equal to 40 times another decision variable.
Okay, times a y, right?
Yes.
Because we said in those conditions, to achieve those conditions, we do need to have a binary variable. Otherwise, there is no way to achieve those two conditions, so either this way or that way. Okay, the binary variables are the only way to do it, because binary is like either 0 or 1. So to achieve those conditions, 3 greater than or equal to 40 times y. Okay, from a natural extension from here, right? We want 1,000 or 0, so y times 1,000. Okay, so let's check. Okay, from there we get this. But whenever we get a constraint, check to see if it fulfills our need. Okay, check. X3 will be, okay, so when y equals to be 1, x3 will be greater than or equal to 40, right? And y1 equals to be 0. What happens to y? What happens to x3? It's greater than or equal to 0. Okay, so this side worked, this side didn't. Okay, so maybe at least one side of it worked. That means maybe let's add one more constraint. So this side will also work. Okay, if, for example, this side we tested and this side didn't work, this is like x3 less than or equal to 40. Yeah, then it probably means it does not work. Let's change it to a different constraint. Okay, but in this case, at least this side worked. Okay, so if this side worked, that means let's try to see if we can add constraint so we achieve what we have. So what do we want? What's the other condition we want? Besides greater than or equal to 40. For x3, what do we want? Equal to 0, right? So x3 need to be either greater than or equal to 40 or equal to 0. And that's what we want. We want it to be equal to 0. Okay, and what we have is greater than or equal to 0. So what do we do? This is what we want. So a hint I'm going to introduce here is that, okay, if you want to force a value to be equal to something, say equal to be a, what you can do is introduce a constraint on two sides. Say a times a y, a, okay, or a times a y on this side, x, or another one. I'll finish this. A y1 less than or equal to x less than or equal to a y2. Remember this trick. It will help you solve problems much faster. Okay, so when you want something like this, first thing you can try is this. Second, switch the side. Third, put y on both sides. Look, see if it makes sense. When you try to force a value to be equal to something, but you cannot write, like in this case, you can't just write, say, x3 equal to 0, right? But you cannot write as a constraint like this. When you put something like this, when y equals to be 1, in both cases, your x will be greater than or equal to a, less than or equal to a. What do you get? Equal to a, right? Same as this one. X less than or equal to, greater than or equal to a times a 1. So when y is 1, you still get x greater than or equal to than a and less than or equal to a. Okay, that forces x value to be equal to a. Okay, and in some situations, you may need to have binary variables on both sides. Okay, so when both y's are 1, still you can get x equal to a. Okay, so with this trick, what can we do? Now we have x3 greater than or equal to 0 when y equal to 0. But what we want is x3 equal to 0. Okay, and what we have here is x3 greater than or equal to 40 times y. What we want is to force it to be 0. So with the same concept, not exactly the same. Okay, if we want to force this x to be 0, when y equals to be 0 here, you want this value to be 0 too, right? But you can't just write a 0 here. Y? Okay, good. Okay, so put a y here. So when y equals to be 0, the same y, right? You need the same y. When y equals to 0, you get 0 less than or equal to x3 and greater than or equal to 3. Oh, sorry, 0. Then you get x equal to 0. Okay, but inspect. Okay, inspect this condition we just added. Is there a problem with it? Okay, good, good. If you write like this, it does help us to achieve what we want, x3 being 0. Okay, but we're limiting x3 to be less than or equal to a 1 value. So what did we do in the previous case? Remember that? So with this condition here, what we are saying is x3 is less than or equal to y. Okay, and y can only be 0 or 1. And what we are saying is x3 is less than or equal to 1. But what is the upper limit of x3? Okay, so we need a big M value here, right? So we time this big M to the y so that we don't limit our x3 to increase. Adding this big M value, which is numerical value, okay? Adding this value here does not interfere with what we want. When y is 0, we still get x3 equal to 0. But we're not limiting the x to increase, okay? And if you look back, remember, that's the condition I asked you to remember. We already have it here, right? In the previous problem. For x3, we already have this. So to build on this model, just by adding that one additional condition, saying, okay, this company does not want to produce product 3 unless it produces at least 40 units. What we're going to add will be, okay, x3 less than or equal to this 75, y3. That's what we have here. But greater than or equal to this 40. And we can have, and we need to use the same y. Okay, so that's what we came up with. Okay, so instead of this constraint, we're going to change this to this constraint. Okay. So now this is the second constraint that's really helpful. Second type of problem that's really helpful that I need to remember. Okay, and I'll summarize it here. This is what we have. And in this case, this big M is equal to. Okay, so this constraint helps us to achieve. So write down on your note, okay, if x1 is greater than 0, then x1 have to be greater than or equal to I want to use a say minimum order size, have to greater than or equal to s. Okay, and this s is a numerical value. Okay, so the condition, if x1 is greater than 0, then x1 has to be greater than or equal to a numerical value. The constraint that we're going to use is x1 less than or equal to a big M, which is the upper limit, okay, of your x times this y, and greater than or equal to this s times your x1. So write this down on your notebook and take a look every day before you go to sleep to remember this, okay? And here, this S is the minimum size. Minimum size. And M, okay, S. And M is the upper limit of x1. Okay, so remember this one. I'll let you write down and I'll further explain it. Help you remember it better. Done? Okay. So what I'm not suggesting you that to learn OR in a way that you just recite and remember those constraints. No. If you understand, if you get really familiar with the process to come up with those constraints, you don't need to. Okay. When you see the problem, you can find out. You can work out the constraint. I still prefer like the logical thinking way to come up with constraints. But why I ask you guys to remember this is to help you formulate a problem quickly. If you have the knowledge on this, and when you try to formulate more complex problems, you build on this, then you can quickly formulate the problem. It's not like every time we have to calculate from 1 plus 1 equals to 2. If you remember it, right, you don't have to deduct, okay, 1 plus 1, y equal to 2. If you remember it, then you build on more complex knowledge. Okay, and this is a really important constraint that you can relate to later in this chapter. Okay, it's kind of like we started with, okay, project 4 cannot be chosen unless project 5 is chosen. I ask you guys to remember that constraint. Okay, and so later when you see similar conditions, you can relate to that condition, that constraint very quickly and modify on that. This is the one you need to remember. And it's actually pretty easy to remember. You just remember that this S is the minimum size. So you just remember, okay, it's x1 need to be greater than or equal to this S. So of course you can just put on the other side, right? If you put on the other side, it's like less than or equal to this S. X need to be greater than or equal to than this S. But you multiply a y, a binary variable, on that side to make sure the other condition, that which is x need to be equal to 0, will also be achieved. And then remember to add on the other side, x less than or equal to its upper bound times a y value. Okay, so that should be pretty easy to remember for this condition. Okay, so, oops. So this part, very important, very important.